Okay, so let's just do an example. So here's the equations of motion we had from before. Let's go have a look at a really simple example and see how to do it. So let's just think of a car starting at rest and accelerating to, say, 100 kilometers per hour in how long? What would be reasonable? How long does it take a good car to go from 0 to 100? 4 seconds? 4 seconds. 60 seconds. That sounds like a Nicolas Cage movie. Yeah. Okay. So a car accelerates from 0 to 100 kilometers per hour in 4 seconds. Okay. And the question we want to ask is, how long a racetrack do you need? So, what distance does it cover? I know it's a quarter mile long enough. Okay, so that's the sort of question that we're going to have to deal with here. Some that are slightly more complicated. To do these things, there's 2 things you need to do before you start. One is check the units. Make sure the units are what you want them to be, otherwise you're going to end up with all sorts of weird answers. And the second thing is that you need 3 things. Okay, to drive any of these formula, because all the formula have got 4 letters in them, 4 different letters. So to drive any formula, you need 3 things, and then you can work out the 4th one. So when you read a question like this, there should be 3 bits of information in it. If there's not, you've got to find out an extra bit of info. So here there's 3 numbers, so it looks promising. So that looks good. What about the units? Are all of those things in units that you're happy with? Remembering the units I had up on the board before? What's wrong, Logan? Okay, so for the formula, velocity was going to be in meters per second. So we have to change 100 kilometers per hour into meters per second. And how do you do that, Logan? Okay, 100,000 meters per hour. Yep. Okay, so 100,000 meters over 3,600 seconds, which is, who's got a calculator? 28.8? 27.78. 20. Yeah, it's exactly the same as dividing by 3.6. It's true. Okay, so if you're just doing it, something you do all the time and you get used to it, you can just divide by 3.6 and it comes out the same. Okay, so we've now got 27.78 meters per second. So awesome. So that's the first thing done. Second thing is, which 3 things do we have? So using the letters that we had, remember the letters U, V, A, S, and T are our 5 letters. Which 3 things do we have already? U, V, and T. So U is 0, V is 27.78, and T is 4 seconds. Okay, so we've got the right units. We've made sure we've got 3 things we need. Next thing you normally do is pick a formula. Okay, so here's your choices of formulas. You want to pick one that's got the thing you want. Okay, if you don't have the thing you want, it's not going to be much help. And then the things you've got, effectively. So I always, often on here, I just put down the thing I want as well. So in this case, I want the distance. So I want one that's got an S in it, a U, V, and a T. So looking at the formula on the right-hand side there, which formula are you going to pick? The bottom one? Bottom one makes sense to me. Yep. Okay, so that's got the thing we want, and it's got the things that we know, which is good. 4th thing is to rearrange the formula. In in this case, you don't need to, do you? You want to get the thing you want at the front. Well, there it is. So this is done. This is easy in this case, so we don't have to worry about it. So once you've rearranged the formula, substitute in the values. So in this case, what have we got? S equals 0 plus 27.78 times 4 divided by 2. And then you grab the calculator, so that's going to be 55.556, I think, is it? Yep. 55.56 meters. Yep. So 56 meters is what you're going to need. Seems legit. Okay. So you've experienced that, Nathan? Used to go from 0 to 150 meters. Yep. Getting half a city block. Yeah. Of course, it's not going to actually happen. What's the, if you took your car from 0 to 100 in 4 seconds, what's the assumption we've made here that's not going to be true in real life? Yeah, I'm not about friction, but yeah, friction's an issue. Constant acceleration. You're not going to accelerate constantly. Like even when you change gear, for example, you're going to have a kink in your acceleration. And different gears will accelerate differently. So you're not actually going to get constant acceleration, but this will model it. Okay, so that's the basic process to go through to solve one of these. We'll do a few more examples where maybe we do need to rearrange the formula. That's the basic process that does the job.